What's up, y'all? In this video, we are going to look at some examples of how you might simplify some logarithms. Let's get to it. We're writing the following as a single logarithm. So we're going to use some of our rules of logarithms that we've noted before to combine these two things. Now, we saw previously that if we're adding two logarithms and we've got the same base, well, wait a minute, what is the base here? Now, here's the first thing that you need to remember. If you don't have a base written for a logarithm, you just assume it to be base 10 because we work in the base 10 system. So mathematicians are kind of lazy sometimes. They only want to write what's critically important. So if we already assume that we're working in the base 10 system, we're not going to write it all the time. That's really hard for some math people. So yeah, so if you see just log with nothing in here, just assume this to be base 10 and this to be base 10. Okay, so log base 10 of 7 plus log base 10 of 2. What we saw before is if we had logs and we were adding them together, then that was the same thing as having that same base and multiplying those two results together. So here, if we've got these two things being added, then we are going to multiply these, the 7 and the 2. So this is going to be log base 10 of 7 times 2, or log 10 of 14. That is the same thing as this, written as a single logarithm. Now, what about this? Here we don't have anything. We're just adding 1. Well, wait, how do we add 1 to this if we don't have any number? We don't have a logarithm. So we have to go back to one of our logarithm rules. And if we go back up here, we had one result that said if log base a of a, that equals 1. So I want the base and the result here, I want these two things to be the same thing to make that equal 1. So here, if I've got base 5, log base 5, then what I'm going to want to do is I want 1 to equal log base 5 of 5. Remember, 5 to the first power is 5. So this gives us a power of 1. So kind of going back to like rearranging this to an exponential function or just kind of doing your mental logarithms with this, we know that this thing is true. So I'm just going to rewrite 1 as log 5 of 2 plus log 5 of 5. Okay, well now here we go. Now we're adding these two things. It's going to be just like over here. So now I'm just going to multiply these two pieces together. So log base 5 of 2 times 5, which is log base 5 of 10. All right, so there we go. Again, written as a single logarithm. All right, so now what about this one down here? Let's just slide this up here. Okay, so we're going to be subtracting. We've got the same bases, but we've got this 2 times all of this. This has actually got two rules mixed together in the same problem. Go to figure. As you get further into this, it's going to get a little bit more difficult. So if we've got this, let's start with this piece. If we had a number times a logarithm, this thing meant this was the power of 6. So I'm going to start by saying, and that rule was if I had log base 3 of 6 squared, that was the same thing as 2 times log base 3 of 6. Go back to your rules of logarithms and you'll see how that maps out. So I'm going to be using this piece over here. So now I've got this part here is log 3 of 18, and we're going to subtract log 3 of 6 squared. Well, we can simplify, since we're trying to put this as a single logarithm or a single logarithm, we can actually square that out if we wanted. So we're going to have log 3 of 18 minus log 3 of 36. Now, the subtraction rule said, well, if you are subtracting the log with the same bases, you divide these two pieces. So I'm going to have now log base 3 of 18 over 36. And of course, we can simplify this down. These two things are both divisible by 18. They're both divisible by 18, right? 18 times 2 is 36. So we're going to have log 3 of 1/2. So that is our result. Finally, we've got this last one, log 27 over log 9. Now, here are 2 or 3 mistakes that someone is going to make on an assessment. Don't let this person be you. So here's the first mistake that someone's going to make, is they're going to say, I'm just going to cancel out these logarithms. You can't do that. Logarithm is not something you can divide by. You can take an entire side of an equation, or logarithm base something of something is a number, but you can't just divide by logarithms. It doesn't work that way. Don't be that person. The next thing that someone's going to do is they're going to say, division, that's subtraction. But notice the difference here. This is saying just these pieces are being divided, right? So this is not the same thing as log of 27 over 9. It's not the same thing. All right, so don't get these two things mixed up. You cannot do that as well. This is saying you've got this whole logarithm divided by this whole logarithm. What we can do though is we can rewrite these logarithms and see if we can come up with a more simplified way to write this. Let's start by saying, well, if this is base 10, right? So we're going to have log base 10 of 27 over log base 10 of 9. Now you don't actually need to write this, because as you get more comfortable with this, you're not going to be putting the base 10 in there every time. You're just going to write log of 27 over log of 9. But since we're still learning this, I thought I would put it in there for you. So 27 and 9, these things are both powers of 3. So I'm gonna rewrite this as powers of 3. So that's going to equal log base 10 of 3 cubed. 3 times 3 is 9, times 3 is 27. Log base 10 of 3 squared. 3 times 3 is 9. So these two pieces represent these numbers right here. Now what I can do is I can say, well, as we just saw over here with this rule where we're bringing this piece back over here, we can take this exponent and bring it out in the front here. And we're going to have 3 log of 3, or log base 10 of 3, and 2 log base 10 of 3. Now at this point, these things are being multiplied, right? Now these are like terms because we're taking a number times some value. And you can even think of log 10 of 3. I don't know what that is. So log 10 of 3 is kind of like a variable to me. So if I think of 3 times some variable divided by 2 times that same variable, now I can simplify this whole thing and get rid of all of that. I'm not just getting rid of the log piece, but I'm getting rid of the log base 10 of 3. So that whole chunk, because that can be put into a calculator. You can't just put log into a calculator. You have to put log base of something of something. That's one of the reasons why we cannot just divide the numerator and the denominator by log, just the word log. We have to take the whole chunk. Now that we've done that, we can simplify this to 3 over 2, and there is our rational number. So this is one way that you will work with logarithms. There's a few other methods that we'll discuss in other videos, but this is how you can simplify and bring your logarithms together into one single logarithm, or simplify it to a fraction, or sometimes you'll also be asked for an integer or something like that. I hope that was helpful. If it was, make sure you give me a thumbs up, and I'll see you in the next video.